continuous growth. So we're going to look at another formula. I like to call this the PERT formula. And the PERT formula looks at what happens when compound interest becomes continuous. In other words, you're getting interest more often. So right now, you might have noticed in our examples, if it was compounded monthly, at the end of the year, you have more money than if it was just paid out once a year, because you made interest on interest every month. Well, we could compound things daily, and you'd get a little bit of interest every day, but then the next day, you would make a little bit of interest and a little bit of interest on the little bit of interest you made. And on the next day, you would make a little bit of interest and a little bit of interest on the little bit of interest that you made, and then a little bit of interest on the little bit of interest you made a little bit a day ago, or so on. And that would happen every day. So I could go through all 365 days saying that over and over again, make it longer and longer and longer, and you would make more and more and more interest. And what happens is your compound interest formula, that 1 over r to the n becomes e to the r. The number e appears.
Yes.
Which is one of the reasons we have a natural logarithm, because the number e naturally appears in continuous growth. And so most population questions that we try and figure out, like in the world, we start to use e because we say there's so many people that it is almost a continuous growth. Okay? And what rate of continuous growth do we have? Because people are always being born, always dying. Right? Can't really say at this second how many people are in the world. No one knows. Because someone was probably just born as I said that. Right? Probably a lot of people were just born as I said that. And died. It's like happy, sad, happy, sad. You can just, all the time. Okay. So what does that do? What would happen? And so we're going to look at what amount of money, how much money would you earn? You invested at 5.5% for 10 years. Once, if it's compounded quarterly, we're going to do this one first. I'll show you the answer already. If it was compounded quarterly, which means only every 3 months they give you interest. And you only start making interest on that new interest once you get it after 3 months. And the other one, they're giving you interest all the time. You're always adding interest, making interest on interest. It's just craziness. And this happens for 10 years. So when it's compounded quarterly, that $2,000 became $3,453.54. What amount do you think is going to be here? Big number like 50,000, or like a big number like 3,453.55? Well, how does continuously?
Like how continuously is it compounded?
Always.
It never stops.
They never, like they're always paying you interest, and they're always figuring out, like. So I mean, this is not humanly possible to actually do it, right? But imagine every second your bank account goes up by a little bit, and then the next second they figure out how much money they gave you the last second, give you the new amount of interest. Okay? But remember when we did our compound interest, right? How many seconds are there in a year? Right? We initially did our $1,000 at 10%, was our first example at the beginning of the year, right? To introduce compound interest. $1,000 at 10% means you would get $100 at the end of the year. When it's compounded quarterly, they take that $100 at the end of the year, divide it by 4, and say, at the end of 3 months, you're entitled to $25 of it. And then in the next 3 months, you would make another $25 on the 100, but you would also make a quarter of $2.50. Okay? Now, if you were being paid every second, 365 days in a year, 24 hours in the day, right? 60 minutes in an hour, 60 seconds in a minute. So that means that in 1 second they would take that $100 and they would say, you are now entitled to, we'll just divide that $100 by 31 million and give you decimal 0.000003 cents. Nice. Every second. So what does that do? Are you ready for disappointment? And don't say, Mr. JR, every time I come to class, I'm ready for disappointment.
Is that not true the exact same as
You make, in 10 years, $13 more. That is disappointing. Were you not expecting something way bigger? So the compounding periods, yes, they make a difference. And this is the most you would get with the most compounding periods, but not a huge difference. The biggest difference that can be made is what that interest rate is. If you can change your interest rate from 5.5 to 6, right? Still compounded quarterly, I'm going to just see what does a 0.5% make as far as a difference. 0.5%, which doesn't sound like very much, ends up increasing it by $175. Whereas compounding continuously increased it by $13. Interest rates make the biggest difference. So when you're buying your first car and they're telling you, yeah, it's only 9% interest, but the other guy over there is at 5% interest, that's going to make a huge difference in how much you're going to pay for that car. When you're buying your house, try to get that mortgage rate as low as possible, because that's going to make a huge difference on how much money you're going to pay. Not on how often interest is compounded. Now, banks don't do this because then they'd have to give you bank statements all the time. And you go to your bank account and the numbers would be like spinning, right? Every yeah. So most banks will do things compounded. A lot of things are compounded monthly because you get your monthly statement. Sometimes things get compounded daily, but mainly it's compounded monthly. But it doesn't make a huge difference. It's the interest rate that makes the difference. So it used to be that the continuous formula was on your formula sheet, so then you would have to be able to read a question and see the word continuously to know that you had to use the PERT formula. But now, whatever formula you have will be given to you in the question, so you would know that you were using the PERT formula, and you would know what you needed to plug in. But now, when solving for the interest rate question becomes another exponential equation. Again, if we simplify this first and divide both sides by 200, we can now take the log of both sides. And in this case in particular, it's going to be really nice to use the natural log. And the reason for that is because we know the value of the natural log of e. It's equal to 1. So when I take the natural log of both sides and I bring the exponent out in front, I get the natural log of e, which is just 1. So when I simplify, all I need to divide by on both sides is 3. That gives me a decimal 0.05383, which as a percentage would be 5.38%. Here is one for you to try. I'll try it as well. (9.049). Add your units, years.